I'm going to talk about a new set of interface updates so that you'll learn about some of the new simulation tools that we've added to the software, and talk about some of the new models that are available, some of the new unit processes, and some of the other changes and updates that we've made to the existing models in GPSX. And as always, we'll be running a number of live desktop demonstrations so that you can see some of the new things in action. And then we'll wind things up at the end by having a few words about some new things happening at Hydromantis. And then I would like to answer any questions that you might have so that you can ask them live here in the GoToWebinar window. You can go to the questions panel that should be there in your GoToWebinar dashboard, and you can type them there. So what will happen is I'll save up all those questions and then I'll answer them at the end of the webinar. Okay, so just a few words about how new versions are distributed to you. Users with a yearly subscription or active technical support contract will receive version 8 update automatically. So we're shipping them out this week. So if we haven't got to you yet, don't worry, it'll be coming to you soon. You'll receive an email. It'll have a new keycode file attached and a link to where you can download the program that will install the new version of GPSX for you. So if you're not sure if you qualify for an automatic upgrade or not, please just send us an email to support@hydromantis.com and we can let you know all the details about your setup. So when we release new versions of the software, we always try to make improvements both to the software interface side. We're always looking for ways to make things easier and better. We always want to try and make it so that you can spend as much of your time working on the actual wastewater problem at hand rather than fiddling with the details of the interface. So I think we've done that quite a bit this time around. We've really tried hard to make it easier to get data in and out of the software, for example. And we always update the wastewater content as well. So we're looking to add new wastewater unit processes. As I mentioned earlier, there's a number of new objects that you can put on your drawing board now. New biological models, new software features, and so on. And we also, of course, do bug fixes and other things where we know that there's something that could be improved. And so we've made changes and updates as we go along. So most of the features that I'm going to be talking about today are part of the GPSX Standard and Pro licenses. Some of the new features are actually part of the Pro Plus license, meaning you have to have that sort of extra add-on license in order to be able to access those. And again, if you're unsure which license that you actually have, you can contact us and we can fill you in. So as I mentioned, there's so much new material in this new version 8 release that we had to break it into 3 webinars. So I'll just very briefly touch on sort of all of the things that we have before going into some more detail about some of them. So in addition to our regular libraries for our comprehensive model, Mantis 2, which is the one that most people use, and our carbon footprint library, which is the Mantis 3 model, we have a new library now called the sulfur and selenium library. So we're doing sulfur reduction and oxidation and selenium reduction, and we have new biomass types and other things going on in there. We have a process water treatment library as well. So that means that's water treatment as opposed to wastewater. Primarily could be used for drinking water modeling. It could be used for process treatment for industry. And we also have a petrochemical wastewater library for treatment of refinery wastewaters as well. So those are all new areas that we've been moving into. And so you can see more details about that. And last month's webinar, we have 13 new unit process objects, and I'm going to be talking about some of these in more detail today. We have new drawing board features, and as I mentioned, new data handling and data validation tools. There's new ways to output your information, such as new mass balance table diagrams, new word report, data summary features. We've improved the menu functionality to try and condense things and make them a little easier to navigate your way around to the information that you're looking for. And of course, as I mentioned, we've updated many of our existing models, including the Mantis 2 model, where we, as we usually do every release, we sort of touch up the calibration a little bit based on our experience and using the Mantis 2 model over the past year or two. One of the other key features of the new version is integration with Python, the Python programming language. So that is actually going to be part 3 of our 3-part webinar. So next month, I'll come back and talk in great deal. There's so much to see here that it's going to be its own webinar by itself. And there's a whole lot more in version 8 as well. So if you missed part 1, where we covered off a lot of the features of the software and some of the models, you can always go to our YouTube channel. And so it's right there. It's about 40 minutes long, and you can watch last month's webinar there. And just in case you didn't already know, actually we record and post all of the live webinars that we do at Hydro Mantis on our YouTube channel. Okay, so let's get into some details about things that we never got a chance to talk about last time. So one of the things that we looked at doing was a way to make it easier to set up dynamic files for you to be able to read data into GPSX, either to plot alongside the simulation or to drive your simulation if you're reading an influent flow and concentrations, for example. And there are lots of different ways to do that we've had over the years with GPSX. So of course, the most popular ones are the Excel spreadsheet and the tab delimited text files, but you can also connect directly from or to an SQL database. It's not used very much anymore, but we do still support the idea of reading directly from Fortran. And then also, as I mentioned, we have this new way to connect Python directly as well. So those are options, but by far the most popular version is, pardon my phone going off there, the Excel spreadsheet. That's the one that most people use to be able to read things in. So what we did was we then created this file creation wizard. It's a way to nicely set up things so that you can have the spreadsheet formatted in the way that GPSX needs to see it, and so you can just cut and paste your information in. So this is a new button at the top of the GPSX window in simulation mode. You will see this new data files button here. So, and what you can do is if you click on that, it will open up the data files menu. This used to be only available from the scenario menu, but we've now moved it into its own button. And when you click on the new function here, it helps you try and set things up so that you can work with a blank spreadsheet that's already been formatted the way that things need to go. So what I'm going to do is actually show you what that looks like. So here is our GPSX layout. All I'm going to really do is model an influent object in this case. So what I'm going to do is if I wanted to, for example, read in a data file and create one where it would include the influent flow over time, I first of all need to have whatever parameters that I want to be able to plot up on the sliders here. So basically drag the parameters that you want to have in your spreadsheet up there. And then I click on that data file. And then now this allows me to make some decisions about what data is to be used in what scenario and so on. But let's just, for argument's sake, we're making something brand new. We now have this new data file creation wizard that takes you all through the steps. So right now we're going to be creating a file that's going to read input. It's going to read data that is used for the influent flow. And so I can now select from the ones that were available here. So there's only one, we'll pick that one. And you can make a list here of the different things that you want to have available in your spreadsheet. And then you click next, and then you can set this out as the Excel spreadsheet that you want to be able to generate. So you can name it whatever you like. I'm just going to leave it as it is right there. And now it will prompt you, and it will open up that Microsoft spreadsheet. It's now named. It's been added to your either the default scenario or whatever scenario you had specified, and now it's all ready to go with the appropriate headers, and then you can just paste in your data right here, time in the left column and your flow in the right-hand column. So you can use whatever methodology you like to get this set up, but this is a nice way to just sort of get things done quickly and easily as needed. Okay, back to the slides. So we've added a few new features now with our Influent Advisor tool as well. So just to refresh your memory, Influent Advisor is a tool that basically allows you to assess and potentially debug any problems that you might have with your Influent data. So you'll already know that you enter in all the information in your the left-hand column, and it calculates all the state variables and all the composite variables. And if you ever run into a problem like this little demonstration I've set up here, where this particular thing that's being calculated here is showing that it's a negative value. And that's going to indicate that there's some issue that you might want to be able to deal with in your system. So what this means is you need to probably change some fractions, or maybe you should just take a second look at some of the numbers that you're using. What's going on in this particular example is that my ammonia and TKN are almost equal to each other, not leaving enough nitrogen to go around and be spread around all the other places that it's required, like the amount of nitrogen that's tied up in the biomass and tied up in the inert materials and so on. So this is fine, but what happens if I have a large data set where I have different numbers for every hour for a month? That's a lot of entering information into Influent Advisor. What I would rather do is have a tool where it can do that for me. So this new data validation tool basically reads from your spreadsheet all the values that you would be reading into Influent Advisor, and it does all the calculations, and it makes a color-coded report for you that highlights any place where there may be a problem. So that is another button down here, another brand new button in the lower left-hand corner. Down here, the data validation tool, and I can show you that right now. So I have previously made a little example of that. So right now I have a series of things that I'm potentially reading in to the system, and I have a nice spreadsheet already set up with those values ready to go. But I want to check and make sure that all of the rows of that spreadsheet, all of the time steps where I'm reading in data, that they all make sense. I don't want to have, you know, it may be really hard to be able to see, even if you take averages, across all of your time steps, potentially a spot where maybe there's a concentration problem just for a brief period of time. So what I can do is I can go to Influent Advisor and I can click on this data validation button down here. Now, just briefly, I'll take a really minor detour here just to point out that we've actually made a couple of other changes here as well. You can now scroll the input part of the menu here independently than of the rest of the menu. And also we now can open and close many of these variables groupings as needed. And the reason for that is that as we've added more parameters to our model, more state variables and also more composite variables, these menus have become quite long. And so rather than having to scroll up and down, we allow that to also to happen independently of each other. So what I'm going to do is I'm going to show you what that looks like. So over here, you'll note that when I'm in modeling mode, I can click on this button and I can specify the input file that I have already created that has those columns of data in it. So let's browse to that thing. And then now I'm going to create an output file where it will read all of those things, perform Influent Advisor on every single time step, and then create an output for me. Now we throw in a default name. I'm just going to stick with that for now. And then we click on here to validate that data. So the amount of time that this will take is actually a function of how many time steps and how many rows there are in your Excel spreadsheet. So here I have time steps of about 15 minutes for a month. And so this will be done here in a brief moment. Okay, let's open that spreadsheet and see what that looks like. So you can see now what I'm going to get out of this is actually the state variables all the way across here, across all of the columns, and all of the composite variables as well. And it's doing it for every one of the time steps that I supplied in that spreadsheet. So you'll notice immediately if there's a problem. We highlight the row in yellow where there's at least one column where, pardon me, at least one column where you have some negative values. So you can see here there was a brief period of time where one of our concentrations, which one, the XPS, so our phosphorus balance wasn't quite right. Like maybe the data that we were reading in, the total and soluble phosphorus numbers didn't really jive with each other. And so therefore we ended up with some slightly negative values as we went along. So it's a nice, easy way to sort of troubleshoot your data, figure out if there's any real issues in there. And so it's a nice way to sort of highlight those. I know there's another example down here at the bottom where we were getting some negative values of inert materials and so on. So it's a nice way to handle and just double check and validate your dynamic data before you get rolling. Okay. And also, in terms of generating results, you want to be able to get those out. And as you know, we have our Excel spreadsheet report. It generates lots of tabs, all of the data that's available, and you can get time series and columns of results out that you can then make some nice graphs with, and all of the graphics that are in GPSX come out as well. But now we've created, in addition to that, a Word report. So the idea behind this one is, this is a sort of a nicer, more condensed version. It has most of the important inputs and outputs already nicely formulated into tables in Word. And so you'll end up with a table that shows you, okay, for this particular object, here's what you changed away from the default. We'll list the parameter and the units, and then we list the default value and then the value that you used. It actually uses underneath a user definable template for those reports. And so if you would like to customize that, insert your own company graphics or whatever you might like, that can be done. And the overall design of this is, it's kind of there to be really something that you could easily generate and put in as an appendix into your report. That is basically just a short modeling discussion. So this is also a button. This was previously the Excel report button. We've now changed it so that it includes both the Excel report and the Word report. And that's found at the top of the screen. So I am going to just show you that really quickly so you can see what that looks like. So you'll load up any simulation that you want to be able to run. Here, I'm just going to run the steady state solution to this particular very simple model. And then once that's done, this button up here will become active, and then we can generate whatever kinds of reports that we like. So you can see here, here's our standard Word report. There's different options you can include or exclude certain things. I'm just going to generate it with the whole works. And it prompts you where you would like to save that. And then once it's done, we will open that and take a look. All right, and so you'll see we actually put in a nice cover page. We put in a description of your layout, whatever you entered in the plant-wide properties file, and then an image of the layout itself. And then, as I mentioned, all of the input that you used for your model. So for every one of the objects in your layout, we've listed all of the parameters that you made changes to. So all of the default values are shown in one column, and then the value that you used is in the next column over. So we also include all of the output tables, all of the images, and nicely formatted tables there as well. And so I'm also going to slide to the end just to point out that if you, you also get the output graphs as well. And then when you get to the end here, if you've made any parameter notes, so you'll notice that there's that notepad button just to the left, just to the right of all of the parameters in all the menus. If you ever made any notes there, those would be appended to the end of this report. Okay. So that is the Word report. And then I'll also mention the quick tips menus. So you'll notice this is going to be turned on the first time that you go to use GPSX, but you can access it actually anytime that you want to by going to the help menu, selecting on quick tips. It's basically a small window that will highlight and give you a little bit of description about one of the features of GPSX that you may or may not know a lot of details about. So the idea is we're trying to make it so that people can be aware of all of the features in the software. I've had lots of experience over the years of giving GPSX training to people, and they'd say, oh, I really wish you had, this certain feature. And I'm like, oh, yes, we actually do have that, but they just didn't know where to access it. So what we've done is make this little thing that you can pop up at any time. You can have it so that it pops up every time you start GPSX, and you can just browse around and learn a few new things. And there's always a link to places where you can get more detail about that feature. So I'll just mention that it's right here. Help, quick tips. And so here, for example, it's illustrating how I can hide and show the labels that are in my drawing board. You can actually click on this button down here and sort of just browse as many as you want as you go all the way through. Okay. So that's a lot of new interface features. There's probably a few more that didn't get described along the way, but if you ever run into anything that you don't necessarily know about and you have any questions, please let us know. Okay, now I'm going to talk about the wastewater model. So I'm just going to run through all of the other objects that we didn't get to talk about last month. And so I'm going to go sort of very quickly from one to the other, show you a few quick demonstrations along the way, just to make you aware of the various new objects that we have created in GPSX. So there's a lot of them. So today I'm going to be talking about a lot of the ones associated with the solids handling side. So we have two new unit processes that came out of some work that we did with a client over the past year. One of them was for sludge drying. So basically, this is an opportunity to do a little bit of not only mass balance modeling, but energy balance modeling as well. So you can specify the details about this unit and its operating procedures and the temperatures of the sludge coming in and the operating temperature and so on. And then we do some predictions about the dry sludge properties, the mass flow of the dried sludge itself, the energy value of those things, water vapor loss, heat requirements, and so on. So very quickly to show you what that okay. Can you hear me now? There we go. Okay, not entirely sure what happened there, but apparently everything cut out on me for a second, so I apologize for that. Anyway, it seems from the comments window here that everybody can hear me again. So anyway, I'm back. So we'll pick up. I was about to show you a demonstration of our sludge drying model. So just like to point out that whenever we're talking about these new unit processes or any of the processes that you would find in the table here of objects on the left-hand side, almost all of them have a nice example already worked out in our sample layouts menu. So just so that you saw that there, if you go to File and then you go to Sample Layouts and then you go to Unit Process Examples, which is this one, all of our sort of specialty units have a nice layout already put together so you can see the details of how these things work. So, so for example, I was going to talk about sludge drying, so I'm going to open this layout here. Okay, so what I've got in this particular layout is conventional activated sludge, and we can see here that the primary sludge and the thickened secondary sludge, after it goes through this thickener, come here to the digester. Then there's dewatering, and then we go through that sludge drying process here. So I'll just open this up just so you can get a little bit of a feeling for the types of inputs that are required for this particular model here. You know, what temperature you're going to be operating this at and so on. So let's run a model and we can see some of the details about what is going on here. So I'm just going to run a steady state simulation. And once that has been completed here, this particular example also has an incinerator on it as well, which I'll be talking about in a second. So if we go actually to the output menus here, we have a summary of all the important stuff that is part of this model here in terms of the mass flow of solids, the mass flow of the water that's being used and being removed through the drying process here, and a bit of an energy balance. How much of that energy was used to raise the temperature, how much of it was used to evaporate the water, and so on and so on. So there's a lot of interesting details. It's not precisely an empiric model, but it's not a dynamic model in the sense that it is integrated over time, but it does take into effect all of those performance variables that you would expect to find in one of the models that is in our solids handling side. Okay, so I'll just briefly mention then also the sludge incinerator that we also have. Again, it's also a mass and energy balance model. So we're taking the feed in there, and we need to know the details of the incinerator itself, its operation. So we're going to need some inputs here about the physical size of that particular unit, and then also how it is operated. So again, we have to know some details about the temperatures and so on, but you'll also see here that we need to know things like the fuel supply rate and the air supply rate and so on. And there's some parameters here that you can calibrate the performance of the model with as well. So in this particular example, we actually have a controller already set up. If you wanted to turn that on, and this particular controller is set up to monitor the fuel flow and make sure that you achieve a specific temperature. Right, so in this case, this has already been run to steady state, so we can take a look at that energy balance. We can see the temperature that the incinerator was operating at and the amount of heat that was generated by the fuel burning and by the sludge burning and the amount of heat that's lost and so on. And then also some details about the fuel that was going in, the amount of specific heat of solids and heat transfer and so on. We also have some details in here on the energy balance. Nope, sorry, I wanted the mass balance side. So here you can see the amount of ash being generated, for example, and its composition as well. So it's there, it's predicting the performance, and it's predicting the amount of energy that is required to operate this particular unit. All right. So also on the solids handling side, we have a new and updated model for the thermal hydrolysis process. So in this particular case, we'll ask you for some sort of energy input that is reflective about the amount of heating or pressure or whatever it is that you're applying to this particular system. And it's going to convert the less biodegradable forms of the COD that are coming into the more biodegradable forms. And also, so by that, we're going to be able to predict VSS destruction, biomass inactivation, and also the energy requirement to be able to do that. So I'm going to just quickly pause back to that sample layouts menu. We have a nice example of that one already worked out for you here, thermal hydrolysis. And I'm just going to run that one to steady state as well. And this is basically the same layout I just showed you before for doing the drying and the incineration. But we now are taking and doing a bit of sludge pretreatment here through this THP system that's right before the digester. So I can show you a really quick example. What I'm running right now is actually this particular thermal hydrolysis unit is turned off. So what I want to do is compare, for example, what is the behavior of the digester with and without thermal hydrolysis in place. So right now, without any energy input into our THP unit, I'm taking a look at our digester here, and I can see that I've got gas production of 1476 meters cubed per day. So let's turn on that, and then I'm going to rerun it again, and then we'll let it come to steady state, and we'll see how much of an increase we got out of doing that. So because theoretically now we've made it a little easier to digest, a little more readily biodegradable, and we can get a bit more methane production out of that. So this is coming to steady state here. And if we look at that same gas unit, so it was 1478 before, and it's going to be about 1500 and something after this converges to steady state. So it's a nice way that you can use the model just to predict the fate of the solids that are coming around. And you can see that that breakdown of the COD makes it a little bit more favorable for digestion. It also releases back some ammonia and some phosphorus, though, too. So those will also go into their respective mass balances as well. Okay. So I'll very quickly also mention we have an ultraviolet disinfection model. This is adapted and now we've updated it for version 8. We used to have a UV model before, but we've made some changes and given it a bit more of a focus on the energy consumption side as well. And so that is there. You identify the chamber dimensions themselves, the number of lamps and their intensity and how you're operating it. We have some new options there. And that what we do predict at that point is the UV dose and the contact time and the inactivation that comes from that. So again, we have a nice example already put together for you. So back to sample layouts, unit process examples, and UV disinfection. And we can see actually what that looks like here just by clicking on and running a steady state simulation. And if I go to this UV disinfection unit, I can get to the UV calculations and I can see what the, so for example, coliform count would be and the dose and the contact time and so on. We actually updated this model quite a bit on the energy consumption side. So you can see the power consumption when you change the intensity or you change the number of units in surface. Right, okay. So back to the slides to wind up a few things. We also have 3 other objects that I haven't talked about yet, but I won't go into them in too much detail since we're starting to run out of time here. We have a passively aerated biofilm model that's for hanging fabric media where the wastewater is distributed over those and it kind of runs over the surface of the fabric and it's passively aerated from the bottom. That's a new biofilm model that is there. We also have a connecting pipe model. It doesn't actually do anything other than just basically be a long plug flow reactor with no reactions in it. The reason it's there, and actually I've had to use it on a couple projects, is just to simulate the hydraulic delay between units on your drawing board. Occasionally, we make the assumption that basically when it exits one unit, it's pretty much instantaneously arriving in the next one. And that's quite fine for the timescales that we work on for most plants. But occasionally, you might have quite a long delay when it leaves one place and it has to swing around the side and go across the back of the plant or something. And so we now have that there if you need it. We also have a new black box model. As you know, the black box model we have right now just has an in and an out connection points, and you can do lots of interesting things with it. We now have a 2 outlet one that allows you to do flow balancing and mass balancing. We have it kind of set up by default like the empiric dewatering object, but you can replace the calculations for figuring out how much mass goes here or there by having access to the code, and we allow you to change the actual equations there to customize them as you need. So just a few words on upgrades and changes to some of the existing models. That was all the new models that I just showed you. We made a change to the grit chamber. So now the grit that's being removed can actually be connected to and taken to another part of the plant so that you can keep track of those solids. We have 2 new empiric clarifier models, one for primary clarifiers that came from a WEF model that was brought to our attention, and we've been using a little bit. It's based on surface overflow rate. And then we developed our own secondary clarifier empiric model that is a combination of several things, solids concentration, surface overflow rate, surface loading rate. And it takes, so it's not a one-dimensional flux model, but it's also not a simple empiric model. It actually does change with different loadings and so on, the performance stuff. So it's a nice sort of in-between version of that. For our simple 1D models, the full-on flux clarifier models, we've added a new term for compression settling, so very high concentrations at the bottom of the clarifier. You'll get a little bit better prediction of the solids, underflow solids concentration. And for the chemical dosage controllers, that's things like adding acetate or methanol or carbon sources of other kinds. We used to basically have a constant flow or a concentration, but now you can actually have many different options. You can make it paste according in ratio of the influent. We built in a PID controller and many other things. So there's some upgrades there. And lastly, as we always do as things go forward in time, we make changes to our models based on our own experience with them using the models in our own projects. So a few updates that you'll see to the Mantis 2 biological model matrix itself is we've added a number of new composite variables. So you'll see things like total inorganic carbon and total organic carbon, and now those are outputs that you can plot everywhere. We made a slight reduction in the poly-P lysis rate based on our experience over a number of projects recently. And we've added 2 new features for methanogens, one being ammonia inhibition and the other being VFA inhibition for the methanogens. That last one by default, though, has a very high value for the inhibition constant, meaning that it's kind of turned off by default. If you want to activate that, you can lower that number from 1,000, which is where it's at now, down to something 100 or 10 or whatever you like, to sort of bring that inhibition sort of to light and apply it to those methanogens. Okay, so we've gotten now to the end, and so just to wind up, there's lots of new things there, as we've now shown over the last couple of webinars, lots of new interface features, lots of new wastewater content, and we've worked hard to improve our data handling. And a lot of those objects that you've seen are ones that have been requested by people over the years. So if there's a particular unit process you would like to see in GPSX, please let us know. We're always happy to hear about how people use our software and know about things that that you would like to have in it in the future. So as I mentioned, there's one more webinar coming on GPSX. We're going to talk about our Python integration. I'd like to very briefly mention a few things that are coming up in the company here before we move on to answering any questions that you might have. Excuse me. First of all, we're offering some GPSX training workshops just over the next few weeks. One in Dubai on October the 29th and one in Mumbai on November the 1st. If you are interested in attending those or would like to know more, you can go to the hydromantis.com website and see more details there. We are also looking to hire a couple of new junior engineers, and right now we have modeling engineering positions advertised on our website. So visit hydromantis.com and go to the news section, and you can see the details there about and how to apply for those positions if you're interested. So as I mentioned, we are moving on to part 3 next month. So on Thursday, November the 14th at 2 p.m., we will be having our next and last of the 3-part series on what's new in version 8, where we'll be talking about how we have now integrated Python and GPSX together. So I'm going to go through how it all works. We're going to go through 2 or 3 demonstrations where we show how you can control and operate GPSX from Python before, during, and after simulations. So you can pop in and register for that. And then the webinar after that one in December, on December the 12th at 2 p.m., we will be discussing the sludge drying and incineration models that I very briefly touched on today. We'll be looking at those in more detail, how you set them up, what are the things that you can get out of them, and sort of how you can use them to optimize and understand what's going on in your solids handling system. So you can always come to the Hydromantis website and go to the webinar section and sign up for those. We'll also be sending out our usual emails, and so you can keep an eye out for that as well. If you have a suggestion for a webinar topic, please send it to one of our email addresses, webinars@hydromantis.com or support@hydromantis.com. Those will all come to us, and we can put your webinar topic together and get that on our schedule. So lastly, I'd like to thank you. If you have any questions, please type them into the questions box on your GoToWebinar panel. Otherwise, you can always send us an email. There's my email address, snowling@hydromantis.com, if you would like to know anything more about what's coming up in version 8, or anything at all about GPSX or any of our products. Okay, so I apologize for the weird audio thing that happened in the middle there, but I'm glad we got that back on track. I don't see any questions actually at this point, but if you have any, I can hang on here for another moment if anybody has any questions. Okay. Well, I think I've overwhelmed everybody with all the information that we threw out there very quickly. Oh, here's one. I would like to know which type of sludge dryer you followed to design this drying process. Different dryer comes with different efficiency. Okay, so the answer to that question is, as with most processes in GPSX, we don't tend to try and represent any one particular technology or any one particular manufacturer. These are designed to be, as much as possible, a generic representation of those technologies. So you won't. So what we mean by that is that you'll find that anything that would be sort of dependent on the technology is going to be reflected in the parameters that you can adjust. So we do have some abilities to calibrate it for different efficiencies. And so therefore, you'll find some of these parameters are ones that you can change to represent any particular one technology. So I know that's kind of a very vague answer, but basically, not any one particular vendor. We try to make it generic. Also, partial drying and complete drying is different. I believe that we are going for partial drying in this particular case. So anyway, we'll be able to talk about some of those details in the December webinar when my colleague Rajiv Goel will be joining us for that webinar as well. Okay. Well, I think since we don't have any other questions, we will take this opportunity to wind things up. I'm sorry I ran a little bit long, and we hope to be able to see you at the next webinar in November about Python and GPSX, or the one that will be in December about our sludge drying and incinerator objects. As always, it's a pleasure to host you in the webinar today. And if you have any other thoughts or questions that come to mind, please send us an email and we will get back to you right away. Thank you very much, and I'll see you at the next webinar.